Alright, Galafoy and Win today. This is our first lesson and we are going to be exploring physics and measurements. First of all, let us look at fundamental physical quantities and their SI units. In physics, whenever we characterize an object, we typically measure its physical properties. Consider the tree on this diagram, for example. We might characterize it by its height. We might characterize its fruits by their masses. We might characterize its leaves by their areas. The tree, the fruits, and the leaves are what we call physical objects. The measurable attributes, the height, the mass, and the area, are what we call physical quantities. A physical quantity is basically a measurable attribute of an object, or put in another way, it's a property of a material that we can quantify by measurement. Right. All physical quantities possess at least two characteristics. One is a numerical value, and the second one is a unit. If we measure the mass of an apple from that tree and find it to be, say, 100 grams, 100 grams quantifies the physical quantity mass in that it has a numerical value 100 and a unit grams. Right. Now, I want us to talk about fundamental physical quantities. As the word suggests, fundamental physical quantities are those quantities we cannot express in terms of other physical quantities, or rather basic physical quantities, because fundamental also means basic. So there are 7 fundamental physical quantities that exist, and we express these physical quantities in terms of what we know as SI units or System International Units. These SI units are used because of their international recognition. So let us explore them one by one. First, we have length, which has the unit meter, abbreviated small m. And then we have time with the unit second, and given the abbreviation lowercase s, or sometimes written as sec. Then we have mass with the unit kilogram, abbreviated kg. And mind you, these are SI units. All of these are SI units. Then we have thermodynamic temperature with the unit Kelvin, abbreviated capital K. We also have amount of substance with the unit mole, abbreviated MOL. Then we have current with the unit ampere, abbreviated capital A. May I please go back to temperature? Note that the unit is Kelvin, not degrees Celsius. Right? You must take note of this. It's Kelvin, not degrees Celsius. Current, ampere, capital A. And then I've added this one for completeness, but we do not cover it in our syllabus. The luminous intensity, given the unit candela, abbreviated CD. Now, sometimes we can combine these fundamental physical quantities to get what we know as derived physical quantities. So these derived physical quantities have their definitions based on fundamental physical quantities. Take, for example, speed. We know that speed is given by distance over time, or length over time. That's the formula for speed. Notice that length is a fundamental physical quantity, and so is time. The units are, what's the unit for length? Meter, right? Meter per, because we have the division sign. What's the unit for time? Second. So it's meter per second, abbreviated meter per second, or sometimes written in this way, right? And many other derived physical quantities exist, like volume. We have some like pressure, force, and the list is endless, so forth. Now let's talk about prefixes. Prefixes. So what first comes to your mind when you hear the linguistical element pre? Was like prediction, preparation. So it's basically something, pre stands for something that comes before the other. Preparation, prediction, you are saying something about an event before it even happens, right? So now prefixes come before a number. We're just basically looking for a way to simplify a number, but I will talk about that in detail. First of all, consider this number 0.000005 meters, or perhaps a large number beginning with 5 and having many trailing zeros, right? If you write down such a small number or such a big number, first of all, it will be time consuming, and second, your work will be prone to errors. Physicists always have a way out. To cater for this, prefixes are used. Prefixes are useful for expressing units of of physical quantities that are either very big or small. So let's look at this number 0.000005 meters. If we want to express it in prefix form, the first thing we are going to want to do is to express it in standard index form. So if we want to express this in standard index form, we are going to want to express it in terms of a number that's between 1 and 5 and multiply that by a factor of 10. So let's see which factor of 10 we can multiply with. We're having 1, 2, 3, 4, 5, 6 places to the right. Because this number is less than 1, that means we are going to have 5 times 10 to the minus 6, because we moved 6 places to the right. Then that's 5 times 10 to the minus 6 meters. Now this submultiple 10 to the minus 6 is called micro. That's the prefix micro. So we are going to have 5. Okay, the symbol for micro is mu. So we are going to have 5 micrometer. So numbers such as 10 to the minus 6, 10 to the minus 2, expressed as factors of 10 and less than 1, are known as submultiples. And then those greater than 1, such as 10 to the power of 1, 10 to the power of 6, are what we call multiples. So there we have it. We have expressed that number in terms of a prefix. Now try this one. Try to express 4,320 meters in terms of an SI prefix. Let me give you a second to do that. Right. If you got 4.32 kilometers, then you're on the right path. If you didn't, well, there's more to life than being right all the time. So let's explore how we do that. First, we are going to express this in terms of a standard index form, a number between 1 and 10, and multiplying it by a factor of 10. So you start here, we're going to move 1, 2, 3 places to the left. So we have 4.32 times. Now this number is greater than 1, so that's 10 to the 3. It's a multiple. So 4.32 times 10 to the power of 3 meters. And this is what we call kilo. So that's 4.32 kilometers. Well, maybe before I continue, let me just give you a table of prefixes. So we have let's start with multiples. We have 10 to the power of 9, known as the giga. And then we have 10 to the power of 6, known as mega. We have 10 to the power of 3, known as kilo, which is where we got this. And then we have the submultiples. 10 to the power of minus 9 is known as the nano. 10 to the power of minus 6 is known as the micro. 10 to the power of minus 3 is known as the milli. 10 to the power of minus 2 is known as the centi. So all of these are prefixes. We use them to simplify large numbers. Alright.